let's talk about inscribed angles. In a circle, if you take two chords, or really just any two segments, and you kind of create this angle inside where the vertex falls right on the edge of the circle, that's called an inscribed angle. If not a central angle, think of a central angle, the vertex is at the center. If the vertex is on the circle, that's an inscribed angle. And it has a special relationship. Remember, on a central angle, the arc and the angle were the same. That's not the case here. If this stretches way over here, it's going to get smaller. This angle is half of what that arc would be. So if this is an 80-degree arc, this would be a 40-degree angle. Let's try a couple and see if we can figure out. All right, so if the arc is 1/16, remember the angle is half the arc. So half of 1/16 would be what? 58. All right, so A would equal 58. On this next one, remember again that the angle is half the arc. So 90 is half of 180. That's right. Okay. All right, here are some other things, well, they're called corollaries, which means they're kind of a directly related to theorems. It's just kind of an expansion of what you know from the theorem, and then what else do you know? So here are some corollaries. If you have two inscribed angles, and this really looks more like a bow tie kind of thing, but here's what it ultimately is. It's two separate inscribed angles. One of the angles is right here, and the other angle is right here. But if you would notice that both of them land at this spot and this spot, so they're both intercepting the same arc. They both are intercepting this blue arc right here. So if the angle is half the arc, well, whatever that arc is, A is half of it, and so is B. So what it says here is two inscribed angles that intercept the same arc are going to be congruent. All right, makes sense. They got to be the same. It's kind of this bow tie look is what you're looking for. Okay, here's another one. If you have a right angle that's inscribed in the circle, well, this is what we just had on that previous slide. This was a right angle. Do you remember what did the arc have to be? Well, it was 180. And what that means is if your arc is 180, it's really a semicircle. And so this ends up creating like a diameter. And so we do a lot of stuff with right triangles in that kind of a scenario. All right, the last one says that the opposite angles of a quadrilateral inscribed in a circle will always be supplementary. So the angles we're talking about here are angle B and D. Those are opposite angles, and those angles will be supplementary. And then you have your A and your C. Those are opposite angles. They're going to be supplementary. All right, let's use some of those corollaries. Okay, oh, here's that bow tie picture. All right, so what you kind of have to envision here is that you have angle X, which is this inscribed angle, and you have angle Y, which is this inscribed angle, but they are both intercepting this 72-degree arc. And the angle is half the arc. So the angle would have to be 36 for both of them. X equals 36, but Y also equals 36 because they're going to be congruent to one another. All right, in our next picture here, this has a little bit more going on, it looks like. You can see here that you have a diameter going through your circle. So that means this splits off a semicircle over here. And if that's a semicircle, then it's 180 degrees. What do you suppose your inscribed angle would have to be then? Okay, it's going to be 90. Okay, I went kind of out of order. That just jumped out at me. So I'm going to be finding all of these, A, B, and C, but C is going to be 90 degrees. Now, let's work on the A. I talked about this being a semicircle, but if this is a semicircle, the top half is also a semicircle. And so all together, that's going to have to be 180. And I already have 95, so let's do a 180 minus 95 and see what's left for A. So 180 minus 95. I could probably do that in my head. I don't know why I'm doing that. Okay, so I get A to equal 85. All right, and then B, let's see, that's an inscribed angle. And it is right here, angle B, inscribed angle. It's intercepting this 95-degree arc right here. And the angle, the inscribed angle, is half the arc, half of 95. So I'm going to write the angle B would equal 47.5. Okay, so here are some more pictures. Just more of the kind of the same, using those same corollaries and everything you can about your inscribed angles. Let's see what we've got here. I've got 4 things to find: A, B, C, and D. And don't necessarily have to do it in any particular order, but let's see what we've got. Actually, to be honest, the thing that jumps out at me is our C and D, because I've got this inscribed quadrilateral, and opposite angles are supplementary. Opposite angles, supplementary. So D I can just do in my head. That's just going to be an 80 degrees. Got that one. C, I'd have to do 180 minus 96. And it's 84. And now let's work on A and B. All right, so we have to figure out some way. And to be honest, probably what I'm going to do is I'm going to kind of group. Let's work on A. I'm going to group A with this 99 degree, and I'm going to create this great big arc right here, because that great big arc is intercepted by this 100 degree angle. And remember that the angle is half the arc. So if the angle is 100, then this full arc needs to be 200. If the entire arc is 200 and you've got 99 of it over here, then you're going to have 101 over here. So it adds up to 200. All right, and then I'm going to kind of do that same thing to find B. I'm going to kind of erase some of that mess out of there. I'll leave my 101 in case I need it, but now I'm going to work on B. And I'm going to combine it with A. And I could do this other ways as well. This is just what jumped out at me. I'm going to combine it. So together, those create the arc that angle C intercepts. Angle C is intercepting that arc. All right. If angle C intercepts that arc, and I learned earlier that C is 84. 84 is half of some bigger number, 168, I think. All right, so this big angle here has to be 168. And I've got 101 of it used up right here. So that means I need another 67 degrees. And like I said, you could group that different ways and do some different things there. That's just how I got around to it. All right, next picture. Again, finding a bunch of things, A and B and C. Looks to me, though, like B and C kind of create that bow tie picture. Angle B is right here, and that's intercepting this semicircle. But angle C is also intercepting this semicircle. And remember, to intercept the semicircle means they're going to have to be half of 180. So I think B and C are both 90 degrees. Now A is going to be a little bit different. A is the intercepted arc from that angle right there, that 25 degree angle. And the angle is half the arc. And if the angle is 25, then I'll have to double it, and the arc would be 50. That one was a little bit easier, I think. Okay, so then we've got one more here thing to look at, and this is a theorem. It says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. All right here. There's a chord, but rather than creating another chord over here or something, it's a tangent. and the angle that it intercepts is right here. It's that red angle. Well, you can see that the vertex of your angle is C, and it lies on the circle. So I kind of treat it just like an inscribed angle. If the vertex is on the circle, it's an inscribed angle, and the angle is half the arc. So C is half of that BDC. It can work over here too. This is more of an obtuse angle, and this angle here is half the intercepted arc. Let's look at that. On this picture, it looks like angle B is going to be that kind of scenario right there. I got A, I got B, I got C. All right. Maybe I'll try to do them in order this time. Let's start with A. A is an intercepted arc. I'm sorry, intercepted angle. And it intercepts the 52-degree arc. The angle is half the arc. All right, let's look at B. B is that picture where it looks like it's got the tangent. So the angle B is half of this arc, but they didn't tell me that arc. But look, you got yourself a diameter right here. It goes right through the center. This is a diameter. That means this is a semicircle that needs to add up to 180. This is 52. 180 minus 52 would be the arc that I need. This is 128. So now, to answer the question as far as what is B, B is half of that arc. So half of 128 is 64. All right, last one, C. C is this inscribed angle. And we're back to an easier one because they already gave me the arc right there, and the angle is half the arc. All right, that's kind of all I've got for you today. Good luck.